Today you're going to learn about solving logs and the change of base formula. So just a couple things to remember and possibly jot down if these aren't fresh in your mind. The properties of logs that we worked on before and natural logs. Also special properties of logs. So if you don't remember any of these last two properties, I would pause, write them down, and make sure they're in your notes. You're going to need to use these to solve logs. The first thing we're going to look at today is change of base formula. So up to this point, you've only been able to solve logs that are base 10 in your calculator. And what this is if you had a log that was, say, base 7 of 2, that's not a problem that you can do in your head. And up to this point, you can't type that into the calculator. But now you're going to use the change of base formula anytime you have a log problem that is not base 10 to evaluate it in your calculator. So in order to do that, you're going to calculate the log of base 10 of 2 divided by log base 10 of 7. When you do this in your calculator, be careful, make sure you close the parentheses if you need to, so that you don't end up dividing incorrectly. When you do that and try it on your calculator, you should get an answer of 0.356, which we will round to 0.36. Just 0.36. There you go. All right, so go ahead and practice this one. Log base 7 of 12, you can't just type that into your calculator, so you would need to use a change of base formula. So we're going to find the log base 10 of 12 and divide it by log base 10 of 7. So try that. You should get an answer of 1.28. Okay, one last one. Give that a try. And you should get an answer. So it's log of 41 divided by log 4, and you should get an answer of 2.68. Okay, change of base formula is going to be used when we get into harder solving log problems. So just remember change of base as we move forward. Okay, so these are going to be your steps to solve most logarithmic functions or logarithmic equations. So go ahead and pause the video and write down these steps, put a box around them so you can reference them later. Right, so the direction said the first step you want to do is isolate your logarithmic expression. So in this situation, here's our logarithmic expression. We want to get it by itself. So the first thing we're going to want to do is divide both sides by 3. So divide this entire side by 3 and this entire side by 3, these will cancel, and now you'll have log of x plus 4 equals 2. The next step, it said, was to rewrite an exponential form. So this is a base 10, so this is really 10 to the second power equals x plus 4. And at this point, it just becomes a basic algebra problem. So this is 100 equals x plus 4. Subtract 4 from both sides, and you get x equals 96. Now, when you are solving logs, you need to check your work and plug it back into the original equation to make sure that it works, and make sure that you aren't taking a log of a negative number. Sometimes you'll get answers that are actually not possible because it ends up giving you a log of a negative number, and you know you can't take the log of a negative number. So let's look at a couple more examples. So ln of x, you guys have learned that ln of x is really log base e of x. So if you need to think of it like that, go ahead. The first step is to isolate your log. While the ln is all by itself, there's nothing there, so you don't have to do that step. The second step is to rewrite it as a power. So this is really e to the 4th equals x. So this solving log problem is pretty simple. You just would want to go ahead and evaluate this in your calculator. So e to the 4th is about 54.5998. Okay. So then you can just check your work by plugging that back in and seeing, does ln of 54.981, is that approximately 4? And if you did it correctly, it should work out just fine. Okay, next one. Log base 5 of x plus 1 equals 2. First step is your log isolated. There's nothing else associated with my log, just log base 5 of x plus 1, so I'm good to go. So the first thing I want to do is rewrite this in exponential form. So this is 5 squared equals x plus 1, which again just turns into a basic algebra problem of 25 equals x plus 1. Subtract 1 from both sides, x equals 24. You can plug this back in to check your work, and you get log base 5 of 24 plus 1, which is 25, equals 2. And using popcorn method, you guys know that 5 squared equals 25. So we're good to go with our answer. Okay, this one is a little bit tricky. The first step is to isolate your logs. Well, we have 2 logs here. They're both base 9. So when this happens, you need to use your log properties to condense. So it's a plus sign. They have the same base, so we can turn this into a multiplication problem. So this is going to become log base 9 of x times x minus 8 equals 1. Okay, now you're down to 1 log, and you can go ahead and convert to exponent form. So this is going to be 9 to the first equals x times x minus 8. Okay, you're going to want to go ahead and simplify this, so it's 9 equals x squared minus 8x. It's a quadratic, so if you remember from Algebra 1, when you're solving quadratics, you want to get everything on one side. So subtract 9 from both sides, and you get 0 equals x squared minus 8x minus 9. So at this point, you still need to solve for x, and your best option here is to factor. So we have 0 equals x squared minus 8x minus 9, which is going to factor to x minus 9 times x plus 1. And you set both of your factors equal to 0, so we get an x value of 9 and negative 1. Now this is where I was talking about going back and plugging in your answer into the original problem to make sure it works. So our original problem was log base 9 of x plus log base 9 x minus 8 equals 1. Well, if you plug in 9, you're fine. You get log 9 of 9 plus log base 9 of 1 equals 1. And that will end up working out. But if you plug in the negative 1, you get log base 9 of negative 1. You guys know that you cannot take a log of a negative number, so you should automatically recognize that something's wrong. And over here you get log base 9 of negative 9. So that does not work because you're taking the log of negative numbers. So you need to go and cross out that answer. It doesn't actually work. Our only answer is x equals 9. So it's really important that you go through and plug your answers back in to make sure they work. Okay, this one is very similar to what we just looked at before, except we have natural logs instead of logs. So all this is log base e, and you want to use your properties first to condense. So we'll get ln equals 2x minus 3 times x plus 4 equals ln of 2x squared plus 11. Now this is a special situation. Every time before we've never had a log on both sides. Here we have the log with the same base on both sides. So in order for them to be equal, what we're taking the log of must also be equal. So in this scenario, we can ignore our logs because they're both log base e and know that what we're taking the logs of must equal each other. So go ahead and multiply it out. You get 2x squared minus 3x plus 8x minus 12 equals 2x squared plus 11, so then you see you have 2x and 2x, so that's going to cancel. Or sorry, 2x squared and 2x squared, which will cancel. And we have 5x. I'm going to add 12 and add 12, so 5x equals 23. So x must equal 23 over 5. And then you just want to take that answer, plug it back into our original problem on both the left-hand side and the right-hand side to make sure that when you plug in 25 over 3, we are not taking a log of a negative number, because we know that we can't do that. Okay, so that's it. Those are some examples on solving logs. Please bring questions to class.